Hello guys, welcome back today with a new CTF challenge which implies a buffer overflow. We are now on another CTF site, pwnable.kr. So we have the challenge here which tells us Nena told me that buffer overflow is one of the most common software vulnerabilities. Is that true? And that is the description, and then here we have the SSH connection. So we'll go into the terminal and connect, and also the password is guessed as we saw in the description. We entered here in the program, so basically, okay, introduce the wrong password again. Okay, so let's see what we have here. It's a readme. Let's read it, and it says the buffer overflow binary is running at netcat 09000 are both on privilege get shell and read flag. So okay, in order to get a flag, we will need to connect to a remote machine and overflow the binary program that is running there. Okay, so first let's see the C program. We have a main function. Okay, it gets some arguments, and it calls it directly call. Okay, so it doesn't do anything with the arguments. It really calls the func with 0x deadbeef, which stores in the key variable. Then it declares a buffer of 32. It prints overflow me and gets the overflow me variable. And okay, then it compares the key with the 0x CAV BAB variable, and then if they are equal, it will call a system. It will give privilege and call a system function which will reveal the flag. So we will basically need to surely overflow this here, this buffer of 32, and then overwrite the value of the key, which is deadbeef, with the value CAV and this will be those two will be equal, and then we'll have access to the remote machine, and then we can read the flag from wherever it is stored. So basically, if we run the binary both, it says yeah, so overflow me, and if we give some very long input, it will print here because they are not equal, and aborted core dumped. Yeah, so we've written more than we should have written. So basically, if we clear this and let's directly dump the binary, so object dump minus d both, and we go into the main function, which is really here. Okay, oh, we can see that on the stack the deadbeef variable is pushed, and the func function is called at the address memory 11fd with 0x deadbeef as an argument. So it gets here to the 11fd where it pushes the EBP. So the extended base pointer, it tells basically from where on the main stack the function will execute on its own memory zone of the stack. It basically pushes the extended stack pointer at EBP, so where the function starts. And then let's look here what it really does. Here is the printf, so we know that here the overflow me string is printed, and then what it does. Okay, so here basically it calls here the gets with EEX, and what is in EEX is basically what is in EBP at -2C in hexa. So basically we know that the gets is called with the overflow me variable. So basically we know that the overflow me variable is in EAX, and then we know that the overflow me variable is at -2C in hexa. So basically if we go in paint, we have here the stack. Let's say this is the stack, and then we have EBP somewhere here. Let's say the EBP is right here, EBP. And at -2C in hexa, there is the overflow me. So let's say the buffer, let's say so buffer, and that's it at minus 0x2c. Okay, so here is the buffer declared, here is the EBP, and we also know that the extended stack pointer is we will see where it's put. It's basically right now it's on EBP2. It didn't move. Oh, okay, so sub it puts it so it allocates basically 30 in hexa for the overflow declaration. Okay, basically somewhere here right now. So it calls the gets, and then here it compares CAF BAB with what is that 0x8 in hexa on the EBP. So basically we have here something at EBP plus 0x8, so plus 0x8, which here it's the key variable, because we know that when we read the program, we know that CAF BAB is compared to the key variable, and now we know the key variable is at the 0x8 plus 0x8 in EBP. So basically what we need to do is when we read into the buffer right here, so what the 0x minus 2c of EBP, we read here, so we'll need to read 2c bytes to fill, so basically to fill this zone here. We'll get to EBP, and then we need to read another 8 bytes in hexa to fill the zone here. And after we fill those two zones, basically we will get to the key variable, and then when we get to the key variable, we can overwrite the values here, and here it will be CAF BAB. So we'll basically write what is at the 0x8 address right here, and we'll put the value CAF BAB. So it will basically compare CAF BAB with CAF BAB. It will get to this. Jump not equal will not be the case, because this will be equal, and it will give privilege, and we will get control over the remote machine. So basically what we'll do, let's go create our temp directory /tmp/and, let's say, and then I'll go /tmp/and. I'll go here, and let's make a Python exploit. So basically we will work with the pan library, which gives us numerous tools. We will define the connection to the remote server, so it's pwnable.kr, and the port is 9000. Okay, and now we will construct the overflow payload, let's name it like that. And we firstly saw that we need to write 0x2c bytes. So what will you do? Let's say 8 bytes, and we will write of them 2c in hexa first. So now we are at EBP. In the overflow payload, in order to get to the key variable, we will write another b bytes. Let's see, and how many? 8 in hexa we will do. After that, we are at the key variable, and we will simply use the P32 option of pawn, which basically packs bytes in little endian. So exactly how they are stored in memory on a 32-bit architecture machine. So here we'll read CAF BAB, and this will transform the bytes into little endian. So it will be correctly transformed when compared in the binary on the remote machine. Let's print the overflow payload. And now what we'll do, we'll say connection.send, and we will send the overflow payload. Overflow right here, and up here overflow, and here also overflow. Okay, and now connection dot interactive, so it doesn't automatically exits the remote machine after we take control of it. So let's save it. And now Python 3 exploit.py. Okay, it's very strange that this happened. I don't know why it shows this, but let's see. Opening connection to pwnable.kr on port 19. Okay, and okay, it bugged. I don't know what is here. We are switching to interactive mode. We are in interactive mode. And if you do an ls, let's say. Okay, it bugged. Let me run it again. Okay, so now this is what we sent. There are literally 44 A's, which is 2C in hexa, and 8 B's, which is exactly 18 hexa, and the CFE BAB packed as little Indian bytes. So now in a remote machine, if you do an ls list directories, we don't really see nothing right now. Oh, okay, it took something. So we have here the files, both Bonasi, and here we'll see the flags. So let's cut the flag. Let's cut the flag and get the text here. And then we can go here and okay, I'm not authenticated. So basically I log in and okay, so it took it already. It took it, I don't know. Out again, this is strange. So you already authenticated this. Oh, okay. So it took it the first time, but I need to authenticate. I don't understand what was the problem. So okay, this was the episode today of buffer overflow challenge.